Yes, and welcome to the second part of my 128 series. And this time, this is an old 128 I had laying down in my bunker. And this did work when I put it away. We are just going to take it apart to see what's inside and see what we can find out, and we can also use this as a benchmark. Of course, we did discover that there are some differences in the schematics and they don't all look the same. But basically, the main functionality should be the same. And I seem to be struggling here to find a valid screwdriver. And these tools that I have down here in my basement is not totally just me. I also have a 12-year-old son that is borrowing heavily from my screwdrivers and all kinds of things. So yeah, it's always exciting to see what's left in the drawer when I need it. But this time I find one driver that fits, and we have one screw here that totally does not fit. Yeah, I've been away looking for more screwdrivers and I found this blue yellow driver. Try that one, but it really seems like this is different screws than the other ones. Yeah, okay, this one loosened. Let's give it a try on this one then. Yes. You just have to have the right screwdriver. And the right driver on retro equipment is nearly always a Galo screwdriver. Yeah, and this is not original. Someone has been in here before. Was there any more tricks into getting into these? I think the top should just rise. Okay, you have the earth ground wire here. And then you have the LED over here. And you have the keyboard connector. Otherwise, this looks a lot like it's not a Mitsumi as it's in the Commodore 64, but pretty standard, I think. And I'm also going to take out this this cover. Then I will be able to measure on this stuff, and you can see here that someone has been in here before. Not every one of these tabs are closed. And I know that the board with the DCR and the D and normal 128, they are somewhat different, and I don't think it will matter that much when we are doing measurement on basic functionality. This will also need some new heat compound when I put this together. I wonder if this one is the one that was the option ROM that was mentioned in the schematics. But how does this differ from the revision 7 I had here earlier? I don't think it differs much, but the version number was on the underside of the cartridge port, I think, if it's not stated elsewhere. And is there any more screws? I don't think so. Oh, there was one hiding underneath. So I just think it's about just slicing things out of here, like so. And this is also revision 7. Yeah, I might be doing some housekeeping on this before I put it back together, but the first thing I need to do is to check, does this actually work? So we can use this as a base when we are measuring to see what's normal or not. And then I just have to hook it up. And I'm not sure yet if I'm going to use my my capturing device or if I'm going to film off the monitor when I'm testing. It's much easier if I film off the monitor, if I can make a camera setup. But otherwise I just have to wing it. And it's also so that I don't have any capturing device for RGB, so testing the 80-pin output, that is a challenge. I can go and grab a CGA monitor for that. But all in all, there are just some loose ends here that we have to cover before we know what we are doing. But first, this one, measuring up this one, would be second priority. Yeah, this is the C128 plug. Nothing exploded. I have this very old cable that I made for TV back in the day. Let's check that out. It has just a 5-pin for composite video, and it has a SCART out. Yeah, so I just try to connect this video and connect this like so. I got power, and I actually got a faulty 128, and this is probably memory error. Yeah, does it put into see, and this was the 4080 column display piece was in. Yeah, and we do have a working C128. I was fooling myself there. And does it work in C64 mode? 3811 by 3. Yes, it does. So this we have as what should I see, the rock bottom for testing stuff. If it's anyone very similar to this, it's okay. I have one trick I need to pursue here, and that is something I've actually done before. This plug, that is the same plug that is in the back of your unit. It's the one that's used for the video port. You can see here, this is the video port, and this actually fits the square. This, if you take away the surroundings here, and you can also take away the bottom grounding stuff. I'm not sure if I'm going to need it. And then this fits like so. This actually was a fault back in the day when people was able to connect the 5-pin into this, and it's also possible with the square ones, of course, but it takes a bit more work. So I'm just going to measure out what is what here, and I'm going to put this on some perf board, and I'm going to make a breakout so that I have the ports that I need to connect to the other machines. Okay, so this one over here is 5 volt. I take this from the top. So this is bottom view, like so. And here we can see that this is 5 volt and it's the right way. So this is ground, this is plus 5 volt, and then the AC is probably over at this side. Sorry for that. Okay, this is the AC. So this is 10 volt AC. It's over here. And we can check that with the manual and see what it says. Yeah, just to make one thing clear, this is from the service manual and the one we had last time. And this is what we actually have. This is where you plug in your normal power supply, and this is what you have over here. And we have one normal 128 power supply, and we are going to reuse that on our 128D, 128 DCRs. And then we are going to recreate this connector or this connector. And from last video we discovered what was the difference between them. The DCR has the 12 volt into this pin 2, where this pin 2 is unconnected or not connect on the 128D and 128. And this plug is not soldered on the plain 128, but this is the plug that is soldered. So we are actually taking, and I'm just going to change color here. We are taking this round plug that we have plenty of, and we are going to make that fit to the square connector of the 128 power supply. So we are taking a male round plug and make it so that it will fit a square. No, the opposite around. We are taking a female round plug and we are taking a square male plug and make those fit together. And if we morph these two together here, you can actually see that this one here, this here, this here, this middle one, and this here, they actually fit over each other. So if I just remove this piece of plastic that is out on the corners here, so that this plug will fit inside here, we actually are good to go. And I've done this before, so I know that this works. And I'm just breaking away all this plastic, and I put this onto my multimeter, and I'm measuring out what we got. And here we have measured out that the GND is on this line, 5 volt is on this line, and AC and AC. And because these connectors here are not connected, we can of course just place a Vero board like so, and it doesn't matter if we connect these together because they are not connected. So this is what we are going to do. We are going to make this into a Vero board, and we are going to have our ground here. We are going to have 5 volt here and the AC over here. And this we are going to connect so that we are going to make a breakout wire that is going to fit this connector over here. So that is what we are going to make, and that's easy and quite forward. And I'm also going to connect a LED so that we can see that this is plugged in, and I might have to make a LED for the 12 volt too, and I'm also going to connect some means of 12 volts into this so that I have one single power supply going into the 128 DCR. Yeah, I have this 40-year-old piece of Vero board laying around, and I'm just going to solder this in here, and I'm going to make some breakout here for connecting the others. I might also just connect up C64 connector on the other end. Then I can use this as a breakout for a Commodore 64 adapter power supply to use my 128 power supply to my C64, and I can avoid having two of these on the bench at the same time. So that's what I'm going to do, and I need to extend the holes a little bit. I think I might be able to just work them in here. Yeah, I probably will. Yeah, this is the finished product. I also can solder on a plug for a C64 here, so yeah, like this one, so that I can be able to supply a C64 power supply. But then I have to remember the issue. If you have a white power brick, they actually have a difference here in what pins they connect. So I do actually have to have two wires here, or I have to wire up a separate plug with more pins attached to have both these for the 5-volt line that will miss down here. So I can do that, but that's not the top priority. No, it's 128 work. And what I've done here is this is a mimic of the internal plug for the power supply for the 128. And it's actually stated that this is chassis ground, this is key or 12 volt depending on which version you have, and you have ground, you have the plus 5 volt, you have AC, and you have AC 9 volt between these two. And these are the 6 pins that are here. I have not bothered with the chassis ground. The chassis ground is this one, and I could connect this also by applying this so it would rub up against this one, but I didn't bother with that. It's just for test, and this is mainly for noise suppression anyway. And on my plug here I do have 2 extra keys, and they will be outside of the normal area for the plug, and this is an old crimp plug I had laying back in the day. And to supply this 12 volt that is required on the DCR, I have put on a barrel jack here that will supply this 12 volt. So this barrel jack is connected just like so, 12 volt, and I also have here a minus there, and I do have here a resistor like so, and a LED that is connected here, and this is a yellow LED, so that I will see if I have the 12 volt connection into this. So then this will light up yellow, and this here will light up green if there are like so. Yeah, so this will light up green. Otherwise it's just a straight through, and you can see here my remodified connector. It's you need to know what you are doing when you are doing these kind of things, but the placement of the pins here on this one is exactly the same as the holes on this connector down here. That's why it's not anything wrong with doing this. And when I connect this, you can see the green LED is coming on, and when I connect the barrel jack here, you can also see that the orange LED is as it should be. And I can take the fluke and we can just measure out what we have here. So between these two it should be 12 volt, and between these two it should be 5 volt. What we have 5.2, and with these we should have the AC voltage. Yeah, 10 volt AC. So everything now should be ready to connect to the C128, and we are just going to do that. And this is the board that I got from Tommy. I have not been doing anything with it. He has some wires here. I'm not sure, but this might be for the LED. I'm not sure. And he has the power connector here, and he has stated 1 there, and he has stated 6 here. But at the same time it was stated this line here with 5 volts, so I do have to measure that some of these is ground and what is not. So I'm sure I put my connector the right way. And this pin 1 should actually be chassis ground. And it is. And this pin 3 here should be common ground, and that you have down here. So that is okay. This should be 5 volt, and 5 volt I can measure on this one up here. That is okay. And the 12 volt, of course, I'm not sure where it goes, but let's leave that to be. And these are the AC voltage then. So let's just hook this up. Yeah, I might want to insulate this a bit. Yeah, just to make sure that it doesn't short out anything at once when I just connect things up. Yeah, nothing fancy, but just to make sure that I don't. Is that the first thing I do is to short out something. Yeah, but like so. And as I stated, this should be this way around. And this key down here. And then things should come to life. And I can of course connect the video down here. No video output whatsoever. But that is not totally true, because it's generating a black PAL picture with the 15.625 kilohertz signal that is being generated, so there is a black screen. Pushing the reset switch does not help either. It doesn't blink on the screen or anything. I can actually just measure to see that I have 5 volts around on this board. It should be this way around. Yeah, 4.92, so it's drawing some current. I do wonder which was this switch 2 or switch 3 that was reset. But the keyboard on this does have its own connector. I do think it's this that is the keyboard. So I might go down in the bunker and get myself a keyboard to try to connect up to this. That will be easier than making an adapter. VDD, this is 5 volts. This should be reset and it should be high, and if I push the reset it goes low, stays low. Yeah, about 1 second. Works as it should. These address lines here, address line 15, 14, 13, 12, until you come to 11. This is the TA address bus and it's the translated address bus. So these actually looks kind of strange. They really are on a crowded switched bus, that's for sure. But when you come down to this one, they seem pretty normal. This is TA11, TA10, TA9, TA8, and then comes the CAS1. So this is the CAS1. This is staying high and this is staying low, CAS0. IO select, staying low, and then comes all the other control signals. MSY, that has a pulse. MSO, that has a pulse. The AEC, the MUX, yeah, that has a pulse. And then comes the A0, that should have a pulse. The A1, A2, A3, A4 and 5, they are multiplexed. A6 and 7, A8. Yeah, and I just continue around the corner. A9, A10, A11, A12, A13, A14, A15, read write, And P clock to IO, VSS, that should be low. Then comes the data bus, T0, D1, T2, T3, T4, T5, T6, T7, and the set80 enable. And this set80 enable is staying low. And that means, as I read the schematics, that the set80 is enabled and should control the bus. FSDIR low, XROM game low, 128.64. This actually has some noise on it, but it's staying high. And we have the Sense 40, that is probably for this 4080 button. And that was the MMU unit. And I'm also going to take you through the PLA now. I have measured a lot on this board before, but it's just to give you some overview of what I'm seeing. This is the A15, A14, A13, A12, A11, A10. This is the VIC fix something. I'm not sure what that signal is. It's at least staying low. DMA acknowledge, that's high. AEC should be pulsing. Read write should be pulsing. The game, I'm not sure what about that. The XROM, this is cartridge ports, I'm not sure what they. And the set80 enable. And this set80 enable, I don't think it's the same as the other. I might look into that. The set80 enable that we looked on the MMU is an inverted one, but this has no mark on it. And we have a set80 IO here, and that is staying high. And we have the ROM bank. This is the ROM bank 1 or ROM bank E. High, ROM bank high, it's pulsing, and ROM bank low is pulsing. VMA4 pulsing, VMA5 pulsing. BA, I have to check, that is high. And this high BA signal is keeping the bus request pin 25 on the set80 to always be enabled, and it's also keeping the RDI ready signal on the 6502 or 8502 so that it will never run. So it's actually keeping the machine in the set80 boot modus and is not leaving that. And the low RAM and high RAM, they're staying high, and VSS is of course 0. VCC is of course 5 volt. The clock is this is actually 2 megahertz clock. I do wonder what this clock on the VIC-T is running. So this VIC-T is not in 108K modus. It should be displaying picture. And then you have the character ROM. It is always high, so it's never selected. And we have the color RAM, that is being selected. GVE, I'm not sure, it's always high. The IO AC, it's high. The WIC enable, it's high. Yeah, this is in line what we have discovered. This is high, so the VIC chip is not selected. The VIC chip select is an active low signal. I have to look into that signal. COS enable, DWE, direction, IO chip select, that is for the IO stuff, the 6526 and stuffs. And you have the various chip select lines for room 1, room 2. I do wonder what's the difference between the SHA-REN and the SHA-ROM. I might have to read up on that. Yeah, that's the signals we have around here. The VIC chip is ticking, of course. And I also do have, this is some video signal that is showing output, and it's black because it has a very low level, and you only see the sync pulses for start of screen, so all the lines are black. This is the clock actually for the Z80. This is the clock for the like so. This is the clock for the 8502. Yeah, I'm going to show you some more of the signals, but all in all, it does seems like this 128 is stuck in initializing the C80 CPU, and that this Z80 CPU is doing its I/O things. Maybe it's waiting for something on the floppy drive, I'm not sure. But the real strange thing is that Tommy said that he was able to get a picture on this and it was able to start sometimes. And I have been able to start this once or twice with a dead test cartridge when I just have been trying. And I've been trying to see if it's when it's cold and if it's other stuff. So this is a bit of a mystery to me, but we are not giving up on this. Yes, and that's it for this episode. It has dragged along for more than 30 minutes, and that's about my limit, how much video I can edit before I'm starting to get into trouble with the Pinnacle Studio. But I have to give an update on something. We do have discovered that there is a diagnostic and troubleshooting manual for the C128. And this manual actually mentions that there is a diag cartridge and a diag ROM that is specially made for the 128. And that is something I need to get hold of. If this works so that I only have to burn the EEPROM and place it in one of my... I do have several of these diagnostic cartridge. This one from... it's a project from PCBWay, I think. And this one I bought, and I do have an original from back in the day, but with a slightly older software version for the C64. And I want to check if this ROM is working in this cartridge and what it's doing for our C128. And of course I can test this on one of my working 128s. And I do also consider to go into the bunker and get out one 128 DCR that I know is working, or I did know that it was working about 5 years ago. But I have also looked into the other 128 DCR that I have laying here, and this one is one that I actually looked into before. It did have a dead 6526 chip when I got it. It was due to an accident with unplugging a device when it was powered on, and that one is staying in, and the drive is spinning like it's not getting the ready signal on the bus. So that is also something I have to look into, and to make it easier, because I don't have any 5071 drives. So I don't have any mechanism or other means of this at all without taking out that other 128 DCR that I have in my bunker. So I might do that, but there is also some other useful information in this diagnostic operation and test instruction manual, and I might have to go into this in detail. So don't be surprised if I make a video about this manual and this system, but I would like to see if I can burn this EEPROM and make it work in a cartridge first. So that's it for this time. I will probably be releasing a video about this 128 about once a week the next couple of weeks. See if I can get to that. I do have a lot of traveling up for January and maybe for the start of February. I'm not totally sure yet. So how much time I will have to devote to this, I'm not totally sure of. So thanks for watching. Hope to see you in my next one.